Let's discuss question number 67. It states that sum of the two rational numbers is 4 upon 9. The two rational numbers can be. So here to solve this, we'll go option wise. When you will be considering here 8 upon 15 and you'll add it to 16 upon 45, the sum total obtained will be definitely in this case 40 upon 45, which doesn't reduces to 4 by 9. In the similar manner, we will be checking it for other options. When you'll come to option number 4 here, 4 upon 15 plus 8 upon 45 will be taken as sum, and here you get the LCM as 45. That gives me here 12 plus 8, that is 20 upon 45. And 20 upon 45 could be easily reduced by 5. On reducing it with 5, I obtain the value equal to 4 by 9. That means this is the correct answer for the required two numbers whose sum total is 4 by 9. So answer for this question is option number 4. I hope it is clear to you. Let's proceed to our next question. Let's discuss now question number 68. It states that which smallest number should be added to the difference of squares of 53 and 47 so that it becomes a perfect square. So here we are talking about difference of the square of 53 and 47. So this is just like the formula a square minus b square, which is equal to a plus b, that is 53 plus 47, into a minus b, which is 53 minus 47. So here when we take the sum total of these two, this is equal to 100 and their difference is 6. So this value is equal to 600. Now what should be added to 600 to obtain a perfect square? And that number should be the smallest number which should be added to this. The square which is nearest to 600 is 625, where 625 is clearly square of 25. So I will be adding up here 25 to 600 to obtain a perfect square which is 625. So the correct answer out of these four options is clearly option number 2. Here I get the required answer as option number 2. I hope it is clear. Let's proceed to our next question. Let's discuss now question number 69. It states that if a number x ends with a prime number, then cube root of x cannot end with the digit 7, 8, 6 or 3. So here when I talk about a number which is a perfect cube and it is ending with a prime number, let's consider here cube root of 27. So this is definitely equal to 3. Cube root of 125, this is definitely equal to 5. Here cube root of 343, this is definitely equal to 7. And cube root of 512, this is definitely equal to 8. So here I have considered the numbers which are ending with a prime number 7, 5, 3 and 2. You can see that their cube roots are ending with 3, 5, 7 and 8. So out of these options I can say that it will definitely end with 7, 8 and 3, but it cannot end with 6. So here the correct answer will be option number 3 for this question. I hope it is clear. Let's come to our next question. Let's discuss now question number 70. It states that in finding the square root of 841 through repeated subtraction method, number of steps will be out of these four options. Let's consider a number which is a perfect square. Let's consider here 3 square, which is 9. If I'm trying to obtain the square root of 9 through repeated subtraction, then how many steps will be required? 9 minus 1 is 8, 8 minus 3 is equal to 5 and 5 minus 5 is 0. So that means here 3 steps are required. So here this is clearly square of 3, or you can say the square root of 9 is equal to 3. The same relationship will be here in 841. So here we won't be subtracting it again and again, as you are quite aware that 841 is a perfect square of 29. So the number of steps that will be required will be equal to 29 to obtain its square root through repeated subtraction method. So here the correct answer for this question is equal to option number 2, that is 29. I hope it is clear to you. So this was the last question of the mathematics section. I hope all the questions are clear to you. Thank you for watching.